Hello friends, once again heartily welcome to this new video. This is the video number 20 based on the topic solutions. Now in this video we are going to learn the last but very important one more article from this topic, that is what the Vant Hoffs factor. Vant Hoffs factor. So this is denoted by the symbol I, like this. Now try to understand what is this Vant Hoffs factor. So in this case, the qualitative properties of the solutions of electrolyte are expressed in relation to the qualitative properties of the solutions of non-electrolyte of the same concentrations. So that is what? What is that? The qualitative properties of the solutions of electrolytes are compared or are studied in relation to the qualitative properties of the solutions of the non-electrolytes of the same concentration. So that is what. So this can be studied in Vant Hoffs factor. So that's why now see how this Vant Hoffs factor can be defined. So there will be a simple question in the examination. What is this Vant Hoffs factor? Try to understand. This Vant Hoffs factor is defined as the ratio of qualitative properties of solution of electrolyte divided by the qualitative properties of solutions of non-electrolytes. So that is what the solutions of the same concentration. What is that? Try to understand. It is defined as Vant Hoffs factor I. It is defined as the ratio of qualitative properties of solution of electrolyte divided by the qualitative properties of non-electrolyte solution of the same concentration. That is important, of the same concentration. So in this way, in this case, we can write I, Vant Hoffs factor, is equal to qualitative property of electrolyte solution divided by the qualitative property of non-electrolyte solution, that is of the same concentration. Try to understand. Qualitative property of electrolyte solution divided by the qualitative property of non-electrolyte solution of the same concentration. In this way, or mathematically, this can be written like this, that is Vant Hoffs factor I for any qualitative property. For any qualitative property. So this now here, that is for the diffraction in freezing point. Now see delta Tf upon delta Tf0. Delta Tb, that is elevation in boiling point, upon delta Tb0 is equal to delta P upon delta P0, pi upon pi 0. So that is what the qualitative properties for all qualitative properties. So where this the terms which are present above, these represent the qualitative properties of what? For the electrolytic solutions, and the terms with subscript, that is denominator, represent the qualitative properties for the non-electrolytic solutions of the same concentration. Or alternatively, this can be written like this. See, Vant Hoffs factor, what is that? Actual moles of particles in solution after dissociation. That is the qualitative properties of solutions of electrolyte means what? We know electrolyte dissociate, ionizes completely, and that's why actual moles of particles in solution after dissociation upon the moles of formula units, that is dissolved in solution. That is for the non-electrolyte, we know that it does not undergo dissociation or ionization, and that's why the molecules remains as it is in the form of formula unit, and that's why, or this is called as the number of moles or particles found experimentally, that is what practically experimentally, that is, and the number of moles of particles which are observed before the experiment. That is what in the undissociated form, like this. By comparing this, we will get this, or we know that the qualitative properties are directly proportional to the number of particles. The qualitative properties are directly proportional to the number of particles. As qualitative properties are directly proportional to the number of particles, we can write here after dissociation of electrolyte, number of particles observed. That's why n observed. I is equal to what? N observed upon n theoretical. That is what? That is the particles before experiment. Theoretical particles. What will be the number of these particles? So n observed upon n theoretical, that also gives the Vant Hoffs factor. actual number of moles of particles present in the solution and the moles of formula unit dissolved in the solution. In this way, n observed upon n theoretical, that is what Vant Hoffs factor. Or again we know that as the qualitative properties are directly proportional to the number of particles, also are inversely proportional to the molar mass. Qualitative properties are inversely proportional to the molar mass. So that is what, when the electrolyte get dissociated, the number of ions are formed there. And that's why, that is, after dissociation, the number of ions increases there, but the molar masses decreases. As the bigger molecules split into the ions, the molar mass decreases. And because of decrease in molar mass, the qualitative property is inversely proportional to the molar mass. And that's why, for the molar masses, Vant Hoffs factor can be written like this: m theoretical upon n observed. Reverse to this: m theoretical upon m observed. Because the qualitative property is inversely proportional to the molar mass, that's why this can be written in this way, that is in the inversion fashion, like this: m theoretical upon m observed. Or formula mass of substance, I is equal to what? Formula mass of substance upon the observed molar mass of substance. Look at this, that is for the particles, for the electrolyte dissociation, number of particles observed upon number of theoretical particles. And in this case, that is the m theoretical upon m observed, that is formula mass of substance, theoretical mass, and the observed molar mass after experiment, that is the observed molar mass. So in this way, m theoretical upon m observed. Now one should know that in this case, Vant Hoffs factor is applicable for the solutions of infinite dilution. In case of infinite dilution or at zero concentration, we know that all the electrolyte completely dissociates, and due to the complete dissociation of electrolyte, so this is applicable or valid. Vant Hoffs factor is valid, but we have to note that is Vant Hoffs factor is not valid or applicable for the high concentrated solutions of the strong electrolyte. In case of high concentrated solutions of the strong electrolyte, what happens there? The strong electrolyte after dissociation produces the ions, but these ions, because of the electrostatic force of attraction, the ions forms the pairs. The cations may form some pairs, or anions may form some pairs because of the electrostatic force of attraction, and that's why actual number of molecules again reduced. And that's why for the solutions of higher concentrated or strong electrolytes, the Vant Hoffs factor is not valid, or the qualitative properties decreases. Why the qualitative properties decreases? Why the Vant Hoffs factor is not applicable for the solutions of higher concentrations of the strong electrolytes? Reason is given that is what happens here, that is the ions which are produced in the solution. So these ions, either the cations or anions, the cations forms the pairs. Cations form the one or more pairs, or anions form the one or more pairs because of the electrostatic attraction forces, and that's why the actual number of molecules there, particles, are reduced, and that's why Vant Hoffs factor is not applicable or valid for that. Okay, then for this, now see, for the solutions of non-electrolytes, see, let us consider urea or sugar. Let us consider for the solutions of non-electrolytes, urea or sugar. That is for the solutions of non-electrolytes, that is this Vant Hoffs factor is I is equal to 1 for the solutions of non-electrolyte. So that is what, that is the number of particles dissolved are equal to same, and number of particles after experiment and before experiment are same. For urea, this value is equal to 1 by 1, that's why I is equal to 1. Now see, that is for Vant Hoffs factor for the solutions of the non-electrolytes. Solutions of non-electrolytes such as sugar or urea. So both values are same. That is what, the after dissociation and before dissociation. That's why for urea we can write 1 mole upon 1 mole. That's why Vant Hoffs factor is 1. So one should have to remember, for the solutions of the non-electrolytes, the Vant Hoffs value is equal to 1. But now see, for the solutions like this, for the solutions such as here, let us consider KNO3. KNO3, that is the electrolyte, or for NaCl, look at this, for NaCl. So KNO3 dissociates into K plus and NO3 minus. NaCl dissociates into Na plus and Cl minus for these electrolytes. That is the concentration becomes twice. That is all. The ions, number of ions increases in the solution. When KNO3 dissolved, it forms K plus and NO3 minus, Na plus and Cl minus when NaCl is dissolved. And that's why in this case the Vant Hoffs factor, that is 2/1 ratio. That is number of moles C of the electrolyte after dissociation 2 and before dissociation in 1. And that's why in this case the value of I is 2 for such solution. That is what the Na2SO4 or CaCl2. So for such solution, look at this. Na2SO4 dissociates and gives 2 Na plus and 1 ion of SO4 minus minus. CaCl2 dissociate gives Ca2 plus and 2 Cl minus ions. So what is that? Number of ions now here thrice or triple. So that's why the ratio dissolved electrolytes 3 and undissociated form 1 molar mass. So that's why for such solutions the Vant Hoffs factor value of I is 3. So that is all easy to calculate like that. So in this way, now see, that is Vant Hoffs factor can be obtained. So that is regarding to the Vant Hoffs factor. We have to solve numericals. So remember this, what is this Vant Hoffs factor? Then this formulas, that is how the Vant Hoffs factor I can be written for the various qualitative properties. And then next video we will see how to calculate the how these formulas can be written with the help of the Vant Hoffs factor, that is for the various properties. And one more relationship, that is Vant Hoffs factor, how related to the degree of dissociation. So that is the last aspect from this topic. We stop here. Thank you. So I request once again, don't forget to watch all the videos. So very soon, that is we are going to conduct the 24th of this month, we are going to conduct the Google unit test of 50 marks. And that's why in order to prepare for the test, so watch all the videos. So all the videos of this topic solution, and then we will conduct a test, unit test on complete topic. So thanks. So if you have any doubts, so you can ask with the help of the WhatsApp. So once again, thank you. Don't forget to subscribe to our channel in order to watch all the videos. Thank you.